Hello, Mark. I'm good. You? Hello, everybody.
Hello, everybody. Welcome to Skype live stream. I apologize. Daryl said hello before me because I thought I was unmuted. So, welcome, everybody. It is, let's see, the date today. I don't even see my date anymore. My gosh, what's going on? I tell you, we're just having all kinds of crazy stuff going on today. Um, the date today is, of course, June 13th, and we are cranking away. Hope you guys are all doing well. We are as well. We're looking at Measure 3 right here on the screen, and that's a globular cluster. It's a beautiful globular cluster,
It is.
and yeah, it is. And there's our date and time up there. I see Michael was first here. And Keith Evans, hey, how are you? Welcome to the stream. And Elisha Vieras, how are you? I've been following you on Facebook. How are things going? And we have Lubo in China's with us tonight. Good to see you. RJPX is with us. Hello, evening to you as well. We're going to have a good night tonight. It's going to be kind of fun. And Sean Farva. That's not his real name, but his name's Sean. But I'm not going to tell you his last name because, it's a privacy thing, right? But Farva's with us. How you doing, man? And it's good to see you guys here. And we're going to be looking at some fun things tonight. We don't have a moon, so I'm going to take advantage of that. And put my astronomical capability to the test. Meaning, will I fall asleep? I don't think so. And Cyclone is with us. Hey, Cyclone. Good to see you. And I want to just take a moment to share with you that Sky Tour has a couple of things that we're doing for you. If you guys join the Patreon and join at a level of $25 or more, you're going to get a free, I guess it's not really free, you paid for it, t-shirt, a Sky Tour live stream t-shirt. Okay. And if you just want a t-shirt, well, you can get a t-shirt. We'll have them available, and they'll be $25 for the t-shirt. But I just want to let you know that we have those things, and we have successfully started a couple of stores online, and we'll be able to share all that with you very, very soon. Our first products went up in the store last night, as a matter of fact. And Robin Curtis has been more than gracious enough to help us figure all that out, because she is quite knowledgeable about these things. I can't do everything, right? I mean, if I tried, I would do everything equally poorly. So, anyway, it's nice to see you guys. And as I said, this is Measure 3 that we're looking at right now. And Measure 3 is a globular cluster. Those are called halo objects. Those are objects that surround our galaxy, and they actually orbit our galaxy like planets orbit the sun. But they don't orbit in a plane. They orbit in a variety of ways, in a variety of angles to the galaxy, which really makes them strange objects. They were never constrained in an orbit like a planet around a star. All the planets are in a single plane. Globular clusters are not. It's pretty cool how these things operate. And on top of that, all those stars you see in that cluster right there, all those stars are orbiting each other and going around each other in an extremely complex way. We've talked about this before. It's the N, as in the letter N, as in November, the N body problem, trying to solve for where any one object will be at any one time. It's tough because you have to take into account all the motions of all those other stars. Right? Hello, Simon Thompson and Anahata77. Bonnie's here, Daryl.
I saw that. Hi, Bonnie.
Yep. Bonnie lives closer to you, Daryl, than she does to me.
Uh-huh.
Yeah. I have a red Solo cup. That doesn't mean I'm drinking anything crazy. It's red Solo cup. Come fill me up. It's a party or something like that. I don't know. Let's have a party. Anyway, it's actually iced tea. So, I am glad you guys came out tonight because you're the early birds too. Wait until we get going. Um, the other night we had a gorgeous view of a beautiful cloud, a dark cloud, dark nebula, and reflection nebula and emission nebula, all in one in the Rho Ophiuchi complex, which was just north of Antares, the red star that is the heart of the Scorpion. And it's something else, let me tell you. It's really, really a beautiful object. But we're going to try doing a couple other things tonight. We're going to try to do the southern portion of that tonight as well, and then we'll blend those together with the one we did the other night, and we'll have that one available. And, if you're interested, go to skytourlive.com, right, or skytourlive.org. We have both. And we are a nonprofit company now, and this allows us to do more things for you, which are really cool. And so you can head down to skytourlive.org or .com and check out all that we have to offer. We have darkroom prints you can get of all of our best objects, and I encourage you to get those. They can be on paper, they could be on canvas, they could be on metal, they could be framed under glass. The sky's the limit, and you can have everything from a 16 by 20 to I think a 30 by 40 or something images. I mean, they're just incredible images. So it's a lot of fun, and I implemented all the other sizes today because I thought it would be important to kind of make those available to everybody since I hadn't yet. Anyway. Okay, I see Tim F has joined us. Hey, Tim. Tim joins us every single stream. Tim will come in, and his first words, without doubt, are "woohoo." I think he's breaking the ice, but it's nice to see you, Tim. So we're waiting for it to get a little darker out there. As you can see, we're not stacking anything yet, but
I have a question.
Yeah.
Are we going to look at the supernova tonight?
Of course. Yes, we will.
Good.
Hello, Hunter. My son got home from the TV station where he works. All right. Yeah, and I figured we'll start with M3, and then we'll head over to the supernova. I want to get that when it's dark because we want to take a longer exposure of that. And we're going to end up with red sunset light in our image. So I'm just kind of waiting it out, But this is Measure 3, and it is, as I said, a globular cluster. And we will save this as well up on our server.
Can I ask something here?
Yeah.
I see something in your image of red 3. I don't see in other images of, M3. I see something at about the 8 o'clock point, like a dark bar on the left side of it.
This right here?
Farther in.
Right here?
Yeah, right there.
Interesting.
Which I don't see in other images of Messier 3.
All right. Well, the first thing I would do in a case like that is confirm where I am. And it is Measure 3, NGC 5272, which is Melot 119. All right. So we are there. We are in it. Yeah, it's kind of interesting, isn't it? So I don't know why it's doing that.
What if you started the image over?
Well, it's not starting an image. This is live.
Oh. Okay,
See?
so it must really be there.
That's right. That's right. So what I'll do is, we'll just to give you an idea, we're going to take just do like a 1 second stack here. And get rid of this one here. This one brightens it way too much. Okay, this is a 1 second stack, and there's that dark bar in our 1 second stack.
Huh.
So it is there.
Yeah. Well, I know I've said before that when you start looking close at globulars, you can see they all have different features, and like the propeller in M13, or
that's right,
the bright bar in M4 we looked at the other night, and Just think about it, I guess M3 has a dark bar across its lower left.
Yeah, there it is.
Huh.
Very cool. All right. Well, we're not gonna. Again, we're waiting for it to get fully dark, but a 1 second exposure seems to be more than enough to have some fun with. It just looks like it's pulling out everything we actually want to see. Not bad. Let me do a zoom so I can actually logarithmic scale too. So now I can. There we go. So now I have finer control over the data. So let's do this. Pull us in more. And soften noise. And that'll clarify. Yeah, that dark bar is pretty odd. And it's also pretty obvious.
I'm looking at other images of it now, and some of them I see hints of it.
Okay. Hey, Izabela. Hey, Fantasy.
If you started taking longer exposures, I bet that might,
Go away.
Yeah. Interesting
Yeah,
to see that, though.
It might go away because it's being saturated out of existence. Well, we can try it. Let's get rid of this. Well, I guess we could. I should save everything we do. So we'll save Measure 3 like this. Okay, and then we'll save it exactly as seen, and then we'll clear it. And now we will. Let's increase our exposure. Let's do 5 seconds. Okay, and we're going to clear this and start over. All right. And we're at 250 on our sensitivity. I still see it.
Me too.
Yep. Okay.
A lot of nice yellow stars in and around the cluster, too.
True, and they'll become more obvious when we stack a few more images. Hello, James Dugan and Alice Pooper. Nice to see you. G'day, James. How's you doing? Down in Australia. One of my favorite places. And down in Australia, they don't say put another shrimp on the Barbie. They don't do that. I know that because I went to a wedding of an Australian this past weekend. And she said, yeah, we didn't say put another shrimp on a Barbie. I didn't think so.
Is that just a Crocodile Dundee thing?
That's a Hogan. Was it Paul Hogan?
Yeah.
Yeah. Or scriptwriters that don't know any better. These stereotype things. Okay.
I don't think there would be an Outback Steakhouse in the United States if it wasn't for Crocodile Dundee.
I think you're right.
Bloomin' onions and all that. I bet James Dugan's never had a bloomin' onion.
We call them prawns, he says. He's talking about the shrimp.
Of course.
Prawn salad. Cosmic Ray is with us.
Prawns once. I mean, I don't remember if I ordered shrimp or prawns, but those things were huge. They were too big to call them shrimp.
Oh, well, maybe the southern hemisphere, they might be a larger species.
Yeah. Somebody messaged me.
Yeah, that's me.
Oh.
All right.
Roger that.
And so I have to complete that task that I was talking about with you there, and this is pretty. This 5-second shot looks pretty nice. So we'll save that again. Very good. Now, for those that may not remember or just joined us, when you see me saving things, you see something being saved, that line across the top saying it's saved as whatever, those aren't lost. You don't lose these. If you go to skytourlive.org and scroll down to the next section down, it'll say, take me to really cool pictures. And it goes right to our server, and it has instructions there right in that section to tell you how to access the very shots that we just took for yourself and that you can just download. All right? Now, they're not highly processed. If you want highly processed shots, well, you can join our Patreon and see some of the most amazing shots. And if someone out there is one of our Patreon subscribers who sees the shots, why don't you let people know what they're in for if they do get a chance to join our Patreon.
Izabela says there's a new feature down right in the chat window. Anybody know what it does?
What feature is that?
I don't know. I don't see anything different.
Tell us more, Izabela. Cosmic Ray, you can't say shrimp, you gotta say little crustacean. That's funny. Yeah. I don't know, Ray, once in a while you get some funny statements. That's a good one.
RRAA.
Yeah, I'm reading it now.
RRAWWBB.
Yeah, I'm just raw web.
Okay. Good question.
Why don't globular clusters flatten out like galaxies and solar systems do? That's a good question based on what they talked about, how they orbit the galaxy. Because when they were formed, they might have had some orbiting stars that orbited flat, but they were, for whatever reason, when they formed, stars were coming in from all directions in such a way as to completely disrupt any orbits that were formed early on. So the stars themselves, with their own gravity, prevented the stars themselves from forming a more orderly system of lots of stars orbiting other stars. It's really organized chaos, you know, and I think that's kind of cool how that happened. But that's a really good question there, Raw Web. I like that. Thank you for participating. That was good. Okay, Izabela says in the chat window, looks like a little circle in the chat window with a heart. When I click on it, or when you click on it, hearts fly in the air but don't do anything. Oh. Okay. I think that's a little emoticon thing that you can click on.
I see a smiley face at the bottom left of the chat window.
I don't see it because I'm not looking at online.
Maybe it's just because my chat window is very closed up, so it fits on the screen with the observatory view.
Yeah. Indeed.
And the yellow stars really do stand out now.
Yeah, I figured we needed to wait a little longer, and we do. Hello, Sam S. How are you? Yeah, okay. Let's, Now, we've stacked, believe it or not, 60 of these, and that's because it was a short exposure. So what we're going to do is just do a little correction. Little color correction here. There we go. Now we'll save it. Again, we still have the sunset colors. You see a little red infecting this image. That's because of the sunset colors. It's not fully dark out there, but you can see right behind me here. You can see the telescope from our camera number 2 position. This is our camera number 1 position right here. And of course, this one here is the computer of the telescope, and the telescope control here, stacking window there, and over here is the camera control cluster over there with focus control over here and so forth. So it's actually a very nice setup, and it'll just be another month or so before we're ready to hopefully install the third telescope. in another location out there. It'll be west of the current location, actually farther into dark sky, if you can believe that. So that'll be neat. All right, this is cool. All right. One last save of Measure 3, Globular Cluster. And let's go see just how much sunlight. Yeah, you see that glow? That's all from the sun. You know, the sunset colors.
Yeah.
Okay.
Twilight's in about 6 minutes, I believe.
Yep, we have just a few minutes to go. So we're good. We're doing better. Okay. Let's go check out our supernova, and then let's go look at some new things. Okay. So first things first. We got this. That's going up to the database right now as we speak. Up to the server. You'll be able to see that in just probably 30 seconds. If you're interested. Okay. Now, first things first, let's tweak our computer, get our image back, and we're going to be in our guiding panel here, but that's fine. Now, I'm going to bring up the other thing that we always bring up, and this is our live planetarium that we see here. Now, we are really close to a number of interesting objects right now in the sky. Okay, and one of them is Measure 101, and we want to check that out. Measure 101 is actually a little bit farther north and to the east a little bit, and it's the galaxy that has a supernova in it. It's also known as a pinwheel galaxy. If you watch the telescope, you'll see which way it's going to go. It's going to kind of lean back a little bit. There it goes. And we'll see Measure 101 as a little fuzzy right there. And then we'll bring it on in as soon as it comes, as soon as the telescope stabilizes. And there we go. Now we're going to move a little bit to the west.
If its brightness hasn't by much, I can already see it.
Oh, I see it, yeah. Yeah.
Right where we left it.
Right where we left it, yeah. And we'll show folks this. All right. There we go. Okay. And a little more to the west to center it up. Okay, one more jog. Oh yeah, there was an auction of telescopes today, and I didn't find out about it until yesterday, and it takes 24 to 48 hours to be approved to bid on things. And we could have had an 11-inch Celestron Rasa or a Celestron 11 CPC. We were looking actually to do that with the donated funds for the next telescope that have been given to us by our donor, one of our donors. All right, here we go. So this will stabilize, and you'll see it says searching, and it takes about 14 seconds for it to identify a guide star up there. And when it does, it'll say 0.0.0.0, saying it's initializing the guide. And then there it is, and then it starts to guide. All right, and once it starts to guide, I let it stabilize a little bit more. And now we can do we'll do 15 seconds on this right now, just to catch the, make sure that we've got not very much glow from the sunset anymore. We're really almost at the end of astronomical twilight. Hey, good. We're good. There's our galaxy right there. What a beauty. It's a beautiful pinwheel. There's a little red from the sun, still the sunset. Let's actually darken this up a bit. Yeah, that's gorgeous. Now, if you're wondering what we're looking at, for those of you that may have forgotten or don't know quite where to look or don't remember where to look, let me show you. Okay, and I'll do that first by zooming in a little bit more. It's not, we have to stack more images on each other to get rid of a lot of the noise, which we'll do. But it's actually pretty good right now. So what I'm going to do is bring up a system I love to use, which is my telestrator system. And right there, you see that white dot I'm pointing at? That white dot is a supernova. It's a star that has exploded in a galaxy over 20 million light years away. And it's really beautiful. And it's also poignant. Because if you think about it, in the time it took for this star to exhaust its supply of hydrogen, it had to be a massive star to go supernova. So the likelihood that there was a planet around that star that may have had life on it is actually kind of slim. So that said, the fact that it's exploded means nothing for the star itself or any planets that might have been around the star, because most likely they were lifeless. However, it could mean something for neighboring star systems that aren't lifeless, potentially. If a supernova went off around a light year away from us, it would do us in. If it went off maybe 3 light years away from us, it could do us in. And that's because of the massive outflow of radiation that would come off of the star once that happened, number one. And number two, there would be a debris cloud that would eventually reach us. And that will be hot ionized plasma in the remains of the star that was thrown off and blown off. So, that's the kind of thing that happens with supernovas. And so they are the great givers of life and the great takers of life. Without them, we wouldn't have the elements in our periodic table. But with them, we run the risk of being obliterated by them. Lucky for us, we do not have any large, massive stars around us that could cause us to be destroyed. And there's none projected. So, good morning, Asheriel. How are you? Or good evening. I forget where you are, Asher. That's why I thought you might have been overseas.
Michael H. has a question of you.
Okay. Michael H. is one of our he's one of our guys that loves to hang out here. He is a staunch supporter of SkyTour Livestream. Hello, Michael Hedrick. Wet Shaves is his moniker. In the Astronomers series, they had to rock the telescope in one location. What? They had to rock the telescope in one location so it could start to recognize the faint stars. Do you know why?
I think I might need a little context for that.
Me too. What location and what kind of scope was it, Michael? Normally, to lock onto a radio source. Oh. Okay, hold on. You're talking about radio sources. All right. Okay, now I get it. Okay, well, I think you're talking about radio sources. The other question doesn't sound it. To lock onto a radio signal source, the astronomers would rock the telescope back and forth to find the strongest signal, like a cross-country driver trying to tune into a distant Yankee game.
Well, that's different. That's context right there.
Yeah, but that's not what he said up above.
Well, I know that. That makes a little bit of a difference, Michael.
Well, let me answer your bottom question here. Radio sources are not going to be visible. So you have to try to identify what stars they are coming from, or what objects they're coming from in a field of stars. So to do that, you do move the telescope to one side, and then you see where in the field your radio signal is coming from, and that helps you identify it. All right, and if you're doing it with a radio telescope, well then it's a giant dish. And I see, as RJPX points out. Okay, that is exactly what he's talking about, and I think RJP has nailed it, saying that you rock the radio dish slightly to help hone in on a pinpoint source. That's correct. And once they do that, they get the strongest signal. Now, you know what else is happening? When I actually do the focus, which I've already done, I do just that. I actually defocus the telescope, and then I allow the focus to shift through a whole bunch of ranges, all right, until it finds a range where the bottommost point is the most sharp image of the star. In your case, the topmost hump will be the strongest signal coming from the radio source. I did this with a radio telescope that I built. Okay, on a mountaintop, I was working for a science center at the time, and we created this radio telescope to listen to Jupiter's moon Io, which had it would generate radio signals generated by its sodium torus, the sodium ions and that are around Io, and so that motion, moving the telescope to hone in on the I'll say brightest part of the radio signal, is something that you would do, because remember, you're not seeing anything in the visible range with a radio telescope. So hopefully that helps.
What you call brightest, I mean, would that be analogous to loudest for a radio telescope?
Yeah, loudest or brightest radio signal. Amplitude is what we're talking about here. Okay, highest amplitude for the radio signal. Yep. Wow, look at this. This is really pretty. Looks good tonight. We have some good imagery here. And if we... so that's the supernova at the end of that arrow. Okay, so what I'll do now is let's color correct. Make this color correction one more time, a little more. Okay, pull that out. All right, now let's see if we can just process a slight bit. I'm going to move our dark range in to add some contrast between the galaxy and the space behind it. Wow, that's nice. But that was a good question, Michael Hedrick. Thank you.
That was a trick question.
I just think that he was struggling to try and figure out the right way to ask it, and I can't blame him. It's kind of a sticky question. Yeah, he says that it was so exciting to see how the astronomers got so excited when they locked in or they started to show on their old computers. Yeah, when these things showed up. Yeah, I gotta tell you, my first imaging that I did was on an old CCD camera from the SBIG Corporation called the ST4. I did that with my friend John, who passed away, but in fact, the East Coast Observatory is named the John Zach Memorial Observatory after him, and we were dealing with just 256 colors. We have millions here. Okay, there's millions of colors in this image, but we only had 256 colors, and I have to say it was so exciting to see that. Just that, what an amazing image we captured. And we wrote a program called ProcessPro, and ProcessPro was used by the Hubble team early on to do analysis of some of the early Hubble images, which I thought was just crazy. And we're like, yeah, cool, go ahead, use it. We didn't have any problem with it. That when you do something like that, you just care about the science. You don't care about credit or anything like that. So we didn't care. still don't. I'm very pleased they used it initially. And then they quickly started to write their own software once they realized that Hubble needed to have glasses. And some of you may know that Hubble Space Telescope needed glasses because they ground one of its lenses wrong. And that error was done right here in Connecticut, at Perkin-Elmer down in Danbury, Connecticut. So, not too exciting. Okay.
Story I heard was they put a certain spacer in backwards when they set the mirror up on the test stand.
Yeah, I don't remember actually.
The story as I heard it, when they designed everything to establish proper spacing, there was a pin that was supposed to be inserted, and it had one square end and one radius end, and they accidentally put the square end where the radius end was going to go, which very slightly changed the spacing, and they grounded that figure, and they took it out of the grinder. It was grounded the wrong figure.
And they never noticed it until it went up into orbit.
Yeah, you'd think they would have.
I would hope they would have.
Oh, yeah.
Yep. All right, well, there we go. That's our galaxy with the supernova. Let's zoom in on it a little bit. Interesting thing about galaxies, you can see some interesting objects. First of all, this little red dot, these are random bad pixels from the camera, our camera. And I eliminate those when I do the final processing. But you'll notice that you have these dark lanes of dust in this galaxy. Let me see if I can enhance those for you a little bit. Okay, here we go. And now they'll be enhanced. Here we go. So you can see them a little better now. All right. I see we had a satellite come through. It's made an artifact on our image. Let's cut down that just enough.
Yep. Some of the green dots you see are real. Those are O3 concentrations. We've talked about that before.
Yeah, like this guy right here.
Yeah, and there's two big ones farther out.
Yeah, that's right out here. And where Daryl's talking about is this guy right here. This guy right here. And this guy right here. And now you say, well, what are those things? What are these things, right? Well, here in this galaxy, we have imaged many times. We've imaged certain objects that are pretty interesting that look like that. And what are they? Well, those are supernova remnants, locations where stars blew up, just like this one right here. And when they made their nebula, as they blew out stuff over years, thousands of years, those nebulae had ionized oxygen in it. Doubly ionized oxygen, to be precise. Oh, look at that. Diagonal Starlink. And the doubly ionized oxygen glows green. Ionized hydrogen glows red. Now, the glow isn't from being ionized. The glow is when the electrons, which are bounced off the atom during ionization, actually rejoin the atom because they've gained energy to leave the atom. Well, they're not giving off light then. They're absorbing it. Okay? And then when they go back into the atom, they give off the light again. They give it back. And basically it's like relaxing, and they come back in and relax. But as they give off the energy again, that light that comes out in the form of light. For hydrogen atoms, it's red, and for oxygen atoms, especially this transition called the forbidden line, or doubly ionized oxygen, it'll be green.
So where we see that supernova now, one day that could be another big green spot.
I suspect it will, as a matter of fact. Pretty cool.
I'd have to wait 500 or 1,000 years for it, but someday it'll be a big green spot.
Well, I have a feeling that next year, maybe the year after, James Webb will image this region and see the infant expansion of the supernova remnant.
That would be cool. Hope they do.
I'm sure they will. It's certainly it's a target now. Cosmic Ray says S big ST4 grayscale. I still have one. Hey, yeah, me too. It's in the back room. Oh no, yes it is. Yes it is. I also had an ST2000XM, S big ST2000XM, which is a color imager, if I recall. And I just gave it away to a friend of mine down in Tennessee who really could use a good imaging camera, so I gave it to him.
What a guy.
Well, I'm hopeless when it comes to seeing people who want to perfect astronomy and do better in astronomy. It's like our friend Michael Tarr. Okay, Michael Tarr is sometimes in here. And Michael works for SpaceX, and I saw him out in California at the last conference I was in last weekend. And he has this program he's working on where he's giving away free telescopes. You talk about what a guy. That's the guy to talk to. You know? Now, he's someone who's very passionate about people learning about astronomy. Without doubt.
More power to it.
Yeah. Okay, we've got 64 images here. We'll save our Measure 101 Pinwheel Galaxy one last time. Save exactly as seen. I want to thank Izabela for putting the links up in the chat for people to go check those things out.
Oh, she's out walking her dog. Let me put it up.
Oh, okay. Well, don't worry about it. She'll be back in. Hey there, Bullwinkle.
Least I can do.
Okay. Very cool.
Gotta find it first. There it is.
Last time we talked about the supernova, we talked about the process that goes into the actual explosion of a supernova. I won't go through that again tonight, but what I will say is that we always will know when there's a supernova brewing out there in the universe, because the thing you see first coming from a supernova or a star that's going supernova is neutrinos. And neutrinos are very high energy particles. They go right through you. In fact, billions of them are going through you right now from all different directions in the universe. All right, and they are so energetic that they go right through the Earth without even realizing it's there. And of the billions upon billions upon billions that are going through the Earth right now, we can trap but just a few. And that's what those giant neutrino detectors deep in underground caverns filled with water are doing. They detect neutrinos. And so before a star goes supernova, the neutrinos get out. Or I should say, 1 out of a billion neutrinos actually escape the star ahead of the shock wave pushing outward from the core that's now blowing up. And because stars are so big, it takes time, hours even, for that shock wave to reach the surface of the star and actually make a visible supernova. So when it's happening for hours. You'll never know it. Hey, Kathy Prentice. So that thing, what I'm getting at though is, we'll see neutrinos, and so for instance, we talked about Betelgeuse before. Well, there's other stars that may go supernova too, like Antares. If we see the eye of the scorpion, or the heart of the scorpion, if we see neutrinos coming from Antares, all telescopes get trained on Antares, because we know that it'll be just a matter of hours, a number of hours actually, and we'll see the actual supernova. So that's why we have neutrino tanks underground. We're trying to find a neutrino stream coming from some point in the universe where we can look and try to pinpoint where there might be a supernova that's about to occur. And Kathy says she just popped in to ask a question. What's going on with Betelgeuse? And Daryl, I thank you. You're actually answering part of it. It was dimming for a while. Then it's increasing in brightness. But Betelgeuse is a variable star, and when we say star, it's really odd looking. It actually looks like it's got blisters all over it. And those blisters are areas where the star's coronal mass ejections are just blowing off the star in all directions. So the star looks like it has these big giant lumps on it. Doesn't look like a sphere. It looks kind of like I don't know what to call it. A rotting orange. Okay, with bumps and lumps all over it. So it's pretty strange looking. But if you, bloated too. Yeah, if you put it where the sun is, it would go out past or at least to the orbit of Jupiter. So it's a star that's over 10 astronomical units in diameter. That's a huge star, considering that an astronomical unit is 93 million miles. You know, so that's pretty cool. Well, anyway, so that said, that's pretty interesting, and that takes us now away from our Measure 101. I have a feeling I'll be able to show people in Roswell when I go there at the end of the month. This, because we're doing a live Sky Tour, live audience event there too. I'll be able to show them this supernova, for sure. And by then, I'll be able to show them some of the other stuff too, coming up in the summer sky. You know, Michael Hedrick says, Mark, has it already exploded for sure? Or are we just waiting on this on the light speed to see it? Michael, we haven't even seen neutrinos yet from it, so I don't think it's blown up yet. I think Betelgeuse is still in the light train that's coming to us. There's no evidence of it having exploded yet, and there wouldn't be until it actually reached us. So it could have exploded. I mean, they're saying it's roughly between 500 and 750 light years away. The jury's out. They keep changing it. But at, let's say, 750 light years away for now, it means that this will be a long wait. If it blew up yesterday, it'll be 750 years before we even see it. You know, but if it exploded 749 years ago, then next year we're going to see a supernova, because that's when the light train will reach us. So remember, this is a time machine. We're seeing this galaxy as it was 20 million years ago. Okay? And that supernova isn't occurring now. It already occurred 20 million years ago. Think about what was happening on Earth 20 million years ago. All right? That's when that supernova exploded. We didn't see the light, though, for 20 million years. Isn't that weird? It kind of makes your head explode a little bit. Not just stars. All right. Well, this is cool. So we've taken this, we've saved it all, and it'll be up there on the server in just a few seconds. Now we'll go back to our night vision mode. Okay, here it is. Kaboom. And night vision mode is good because it's going to help us see where we're going. All right. So. All right. So let's go now and move around. I do want to do one thing, only because we should. I'd like to look at the great star cluster in Hercules, known as Measure 13. I think it's one of your favorites, Daryl, besides Omega Centauri.
Oh, yeah.
Asher's head blew up. I get it. And there's Measure 13. Badoom. Okay. Let's bring up our crosshairs and center it up. All right. Okay, so we're going to go to the west. It's going to be pretty close.
Have you run a focus yet tonight?
Yep, I mentioned it earlier.
Oh,
Yeah, I already did, and I got T-comp, the temperature compensation running.
I saw that. That's why I asked.
Okay. But it's always good to be reminded that, and of course, even with temperature compensation on, fluctuations in the temperature will cause the telescope to heat up, cool off, and change the focus in ways that the equation that I developed for compensating for the way the focus changes with temperature acts. So it could be fooled. And so once in a while, we do have to refocus in the middle of a session. And I don't mind, because it's kind of cool looking to do the focus. People like seeing it. All right, so let's get rid of this now. That's centered up. And let's go to our planetarium. Go center it up. Zoom in and see what we can do. Okay, we're going to actually sync this here. So this will now move to the center of this cluster. There goes a Starlink satellite. The length of that, you wonder how I know that's Starlink. The length of the trail, and that is not Starlink right there. The one that went through before was. Okay, the length of the trail is a certain length, right? Well, at the altitude of the Starlinks and at the 1 second exposure that we've got right here, you can see this 1 second here, right? Well, it's actually here. 1,000 milliseconds is 1 second. Okay, that 1 second trail is exactly the length that we'll see with a Starlink satellite pass. Okay. Now, the Starlink satellite that we see there, that's already in orbit doing its thing. It's not a recently launched one. It's one that was launched some time ago because it's already in its final orbit. It takes several weeks for these Starlink satellites to get into their final orbit once they're launched. Okay, let's go do a 20-second exposure here of Messier 13. The core will be blown right out, but we'll get to see what this globular cluster, this halo object, actually looks like. All right, so we'll live stack and we'll delete the last object, which was our wonderful supernova. It's not deleting it from anywhere but our live stack buffer. There we go. Thank you, Starlink. All right. Let's go in here. And let's see about changing that. There we go. Let's pull this way down. Let's color correct. All right. Let's zoom in. There's only 2 stacked images right now. This is Messier 13. It's the great, beautiful, big globular cluster in Hercules. It's at what's called the Keystone part of the constellation.
I used to be able to see that naked eye when I was young and beautiful.
Well, I'm sure that you could see it naked eye if you had a dark enough sky.
I did when I was young and beautiful. That's when I lived up in the mountains.
In Leadville?
Highest city in the United States, yes. About 10,700 feet, and I could see it naked eye. Light pollution was not as bad back then either. It's getting to where it's showing up even in the high country now. Yeah. Badly some places.
RJPX actually did a little historical study with us. He said M101 supernova originally blew up at least 40 million years after the end of the Mesozoic and the Chicxulub impactor, but still deep into the Pleistocene. Isn't it fun to think about that? It blew up before humans were here, effectively, right? And then we see the light as somewhat developed humans. I just think that's such a cool thing. Yeah, and there's our gorgeous Measure 13. I'm going to just lower this down, and I'm going to get rid of the telescope for now and just go to a full screen just so you can see this. That's pretty. Very pretty. Very pretty. Okay. And what this is Measure 13, a GC, Globular Cluster. We can move that a little down. There we go. Very cool. Now, Daryl likes to point out, let's go over here. There's a little propeller here. See this little tripod looking thing right there? There it is right there. 1, 2, 3. That little 3-bladed thing, that's called the propeller feature in Measure 13. And that's something that Daryl likes to talk about. And I just pointed it out too, I guess. So that's kind of cool. But let me see if we can make it show up even better.
Mark, Izabela
there we
asks,
go.
what is
Yep.
the big red star on the left? Could we possibly go to Stellarium
Sure.
and see if we can identify that?
Absolutely. First of all, let me just show you. Okay, once again, here is the propeller right there. See that vertical? Then you got this at an angle, and then about 60 degrees, you got this one here. Okay, so there's the propeller right there. How about that? Not bad. Now let's go to Stellarium and see if we can identify that red star. So in Stellarium, this is our field of view. Okay, and let me zoom out just a little. Now you see the way you see the way it's way it looks right here. Okay, here's the globular cluster, and here is the red star. The red star is Hipparchus 81848, 81848, also known as from the Henry Draper catalog HD 150998, and from the Smithsonian Astrophysical Observatory catalog it's 65508. It's a K2 type star, meaning it's an orange star, K2, but it's a K2, not sure of its luminosity class. What's that mean? We're not sure if it's a giant or a regular star like the sun. Okay, so but it's a K2, and if you're interested for sure in trying to figure out what these things are, well, one thing you can do is you can look up the star in what's known as Simbad, S-I-M-B-A-D. Okay, not Sinbad the sailor, but Simbad, like The Sims, S-I-M-B-A-D. And Simbad, if you were to copy down any one of these, the Hipparchus number, the HD number, or the SAO number, and put it in, you'd get the star with any history to it, which is really cool. All right.
I bet you dollars to donuts when they named that, they look for cute names all the time.
You know they do, and you know they did. You know they did.
Oh, yeah.
All right. Yeah. All right, let's redock this here. Let's bring back the telescope. There we go. All right. And let me just raise you up a little bit. There we go. And move this over a little. There we are. Move it up. There we are. Good. All right. So now we have our image back. And when I save it, you don't see any of that. You just see the image. You don't see all this other stuff on the screen here at all. which actually might be kind of cool for some, but I don't know. Okay, so this is M13 Globular Cluster, and we've stacked 21. That's more than enough. We can see the propeller very clearly right there. That's good. Now we'll save this exactly as seen. Alright. Alright, good, good, good. Alright, so now we'll get out of this and go into our night vision mode again. Boom, night vision it is. We'll go to 33%. Alrighty, let's see here. And also, just to let you know, when you're looking at the screen, again, for those that may not remember or new here, this over here, okay, this is our telescope control. This is our telescope computer. This is our telescope in the building. This is also the telescope in the building from camera 2. And this is the camera control cluster over here, focus over here. So it's actually kind of cool. Right, and of course, this is Measure 13. Yay! And the other thing too is the most important parameters are. Oh, there's another Starlink. Most important parameters are this one here, the exposure, and this one here, the gain. Okay, this tells us how sensitive the sensor is, and this tells us how long we're going to expose that sensor. So the bigger the gain, the more data we can collect, but the noisier it gets. So, for instance, let's suppose we change the gain now to a much higher number. Let's go up. Notice the screen. Look at how much noise is in here now. But this is at 400 gain. Let's go all the way up. Okay, now we're at 500 gain. Now we're almost at 560 gain. Look how much noise is in this image. Okay, so I don't choose to use it at that high a gain level. I would if I was shooting many shots beyond the 20 or so that we use here, so that I could actually average out a lot of the noise. But I don't do that right now because I have all of you in tow. If I was doing it myself or doing my own session, then I would actually do that. I would spend the time to do it right. All right. Let's see now. Let's bring back the computer. All right. Now, I am going to zoom out of this for a minute. And we got Mission 92, but that's another one. We got Vega has risen over here. Cygnus is on the rise. For you, Cosmic Ray. As soon as it's up, we're going to image. We're going to image the heck out of stuff in Cygnus and go crazy. All right, now let's see. This is Scorpius the Scorpion. There's Antares. Antares is a massive red star. And it is not really high enough above the horizon yet for us. But that's okay. We will. Let's see about this.
You don't think so? I know. We looked at it the other night. We caught it about this time, I believe.
Are you sure?
I think. Maybe it was a little later.
Yeah, I think it was a little later, but I will try it. Here, let's just try it. We'll see what we get. All right.
I mean, it is transiting the meridian at midnight now, at least from here.
Yeah, okay. Let's find out. See, watch the telescope here and see see if this is pointing toward the top of the building. It looks like it's hitting the building. But we see Antares and Messier 4, another globular cluster, right? And we don't need that anymore. Go away. Right? We don't need that, so you can go away. Okay. The halos are due entirely to the imaging system being so fast. It's an extremely fast system.
You see the halo's kind of lopsided on the lower left. I bet that's the roof line right there.
It is. It's the roof line of the building. Exactly so.
Yeah.
So if we took a picture, you'd see kind of a red glow down here, and that'd be the edge of the building. Gladys says, sometimes you forget Mark has another arm. I do. See? I have two arms. Okay. Now what we can do, though, one of the things I want to do is I want to take us a little bit north. And the other night we imaged the northern part of the Rho Ophiuchi Nebula. And what I'd like to do now is image the southern part. So we're going to go to Rho Ophiuchi right now. Alright, and it's just north. And if you haven't seen that image yet, please check it out. You will absolutely love it. Actually, let me see. Let me see if I've got that image. I must have that image. I'm sure I do. Oh, I do. Alright. Let me, well, first, okay, let me just get this straightened out. Okay, so here's the Rho Ophiuchi location. So we're going to head east a little bit. Alright. And let me do that. And we're going to head east a little bit, and then we're going to head south. Now, just to show you what was here, I will first bring us down here. And we're going to see another pair of stars right there. And those stars are in a lower part of the nebula. And you're going to just go crazy when you see everything that's in here. Alright, so I'm going to take us down to just about here. Okay.
He's hard up on the northwest side of Scorpius now. Kind of almost the border between Ophiuchus and Scorpius.
Yeah. Okay, we're doing our thing here. We're going to do a 45-second shot. Alright. I did do that. Okay, good. And here we go. So 45 seconds here. And you just see stars, right? Well, let's see what's really here. Okay. Now there's our last thing we just saw. The anticipation is building.
45 seconds.
Yes.
Pretty long one for you.
Yeah, I don't know. I mean, when I'm working alone, I'll do 1 and 2 minute shots and do like 45 of them. So literally an hour is eaten up just doing shots of one object. I am not going to let all of our friends here be subjected to that, right?
Sure.
I mean, I will at some point, maybe. Let's see here. Well, look at that. Now let's... And now you can see that there are a lot of interesting colors here. Very cool. think this is the Alniat Nebula, which we imaged the other night.
I think you're right.
And this is the lower part of the Rho Ophiuchi complex. The upper part is up here off the screen, and that's where we were the other night. And this will be mosaicked with that one, and then we'll process it together, and you'll see a beautiful processed image. There's so much here that we should technically do a bunch of shots here, go over exactly one whole field, do those, go to the right, do those, go up and down, because it's a massive complex. And this little bit of work that we're doing is just to fill out this bottom part. You can see just this part on it, Isn't that something though? Look at that beautiful thing. And we have very dark sky out there, so naturally we have the ability to keep acquiring more and more data. So let's do that. Let it stabilize. Look at that. Now you'll say, well, what is all that? Well, this stuff here, okay, and it's a lot more down here, as you can see. This is red hydrogen emission right here, okay. And then over here we have more hydrogen emission. That's from the star Alniat, which is right there, okay, just out of the field. And then right here, as we move back up, okay, this is a reflection nebula. That is, there's dark dust. This is dust clouds here that aren't reflecting anything. They're just dust seen in silhouette. You can see the edges of the clouds are sort of illuminated by other stars in the area. It's really almost 3D. And it'll get much, much better as we keep going. We've only stacked 4 frames. Now, the reflection nebula is created because it's made. This is all one continuous dark nebula right in here. But you'll say, wait, that's bright. Why is it not dark? Because these 2 stars are giving off blue light. All right, and because every star gives off a spectrum that's red, orange, yellow, green, blue, indigo, and violet. And as that star gives off that light, the blue light in particular is very short wavelengths, very, very short, okay? Extremely high energy, short wavelengths. And these tiny dust particles in here love to scatter that light. They love to absorb it and re-emit it in all directions, and that's what they do. Our atmosphere does that as well, as we've talked about 100 times. And that's why our sky looks blue, all right? Because the atmosphere molecules are scattering the blue light from our star. So that happens like that for a reason. It's a process we see throughout the universe. It's something that happens in many nebulae, like this one here. Okay, we see the blue right here. You can't miss it. All right. And at the same time, it's mixed with hydrogen emission. It's such a beautiful location. I don't know, Daryl, I just never get enough of Rho Ophiuchi. You just can't.
Oh, it's a beautiful area.
Kazakh Ray, the observatory spider has been bribed to keep the scope away from Cygnus. Just for that, Ray, we're going to do a mosaic of the entire Cygnus constellation just for you. Starting with the Veil Nebula on one side and going all the way to the other side, with an extra focus on the Gamma Cygni Nebula region. I actually did a beautiful mosaic of that whole region last year. It was beautiful. I don't think it's in the other paywall imagery. I'll have to bring that back. You know what? What am I thinking? Let's get rid of this, okay, again. And let's take the telescope out of the way for now. And let's enjoy the majesty of this beautiful image. Wow.
Early on, that bright star to the lower left, it looked like it had an eyebrow above it, and now the red is coming out around it. Some of that looks like halo, but...
well, this is... you see the halo here, yeah. There's no doubt about that.
Makes the whole thing look like a big red eye.
Yeah.
Angry even. Mark, would you excuse me a moment, please?
Sure, go ahead.
Be right back.
Okay, I'm gonna come in here right now, and I'm gonna take off the mask just to soften it up a little bit. Look at that. So look at these tendrils of dark nebula in here. Again, where does that stuff come from? This is the stuff from supernovae, okay? When a supernova explodes, it litters the sky in the universe with all this dark nebula. And that dark nebula, this stuff is made of dust. That dust is made when a star is in its final red giant stage. The star goes into a red giant stage twice in its life. The first, when it runs out of hydrogen. The second, when it runs out of helium, because it fuses hydrogen into helium, and the helium is not fusing in its core. But then, as that core contracts and the star gets hotter, the star expands and pushes those outer layers out. But then the helium can start to fuse into carbon and so forth. And when that happens, the helium gives the star some new life for a few thousand years, and then maybe 100,000. And then eventually, when the helium runs out, the star begins to contract in the core again because gravity's winning out, and that outer layer just keeps getting pushed outward and outward more and more and more. And so that makes the star go into a red giant phase again. And that red giant phase, when those happen, in the red giant phases, those outer layers are so far away from the hot core that's producing all this energy that in the outer layers you can get dust made, molecules of dust. What are dust in terms of interstellar dust? Well, it starts out as silicon and carbon atoms that form molecules of carbon atoms, carbon. So two carbons together, la-di-da, okay, flying through the nebula. But then they accrete other material that's in the nebula. And in the dark outer reaches of these nebulae, it's very cold, and you got there's water out there. Okay, water forms from the hydrogen and the oxygen that's out there. And when that happens, it'll, of course, be frozen. And so these ices, not just water, but ammonia ices and other chemistry, other methanol and so forth, they will also, I said ammonia, they will also accrete onto the dust grains. And so all of this dust is a chemical factory of all the stuff needed to make life, right? And so that's what we're seeing happening here. We're actually watching the universe form new materials from which life can be made. That's really pretty. Look at that. This is a beautiful area. So now we have 12 stacked in here. And you can still see there's some colorful noise in here. That's all going to be extracted as well. Let's remove the time and date for now, because that doesn't need to be there. Let's just keep. I want to keep showing us this. There we go. All right. We'll just wait for some more exposures to come in. Okay. You'll notice as each stacked image comes in, a little bit more of the noise goes away, right? That's what the point of stacking is here, okay? So when we stack, we take an original image, and we take a second image, and we align it with the first and place it on top, and we make an image sandwich this way, and just put image on top of image on top of image. What's that do? It means that anything that's sort of like dark, like space is dark, will actually begin to separate from the background. It separates from the background because of the fact that this data is now, it's there. It's in the nebula. It doesn't go away. So these little faint tendrils that you see right here, these become more and more pronounced as more data is added on top of each other, and the noise that prevents you from seeing them is eliminated as it's averaged out. This is why I'm an astronomer, guys. This is why. Look at this. Look at this view. This is why I'm an astronomer. Okay. When I was a kid, I said I was an astronomer. Okay, because I couldn't even say the word, but I knew I wanted to be one. Welcome back, Daryl.
Thank you. Asher has an interesting question.
Seems like the colors I see are all under RGB. Is that correct? Are there elements that reflect more of the spectrum? Let me see if I understand your question. Well, first of all, any color that we see visually can be represented with an RGB value set. A certain amount of red, certain amount of green, certain amount of blue. Okay, so we can change the colors. In fact, what I'll do, just to show you what I mean, let's do this. Let's dock this up for now. And let's show Asher what I'm talking about. See these colors over here? Okay, what if I remove the red? Okay, that's what it looks like if I remove the red. Alright, what if I remove, let me put the red back. What if I bring the red back? Okay. That's too much red. I'll color correct it to the automatic. Okay. What if I remove the green? What do we get? If I remove the green, we get this. Okay. I know it looks pretty, doesn't it? And if I remove the blue, then we get this. Okay. So you can see how our data changes, but you can represent a nebula using all RGB, you see, and likewise you can do it in reverse. And if you do only a little RGB, well, then you might have it look kind of like this, where it's sort of faded, or go here, which is totally black and white. Now, when it's black and white like this, you don't know whether this is ionized hydrogen or you don't know this is a reflection nebula. This could be emission nebula. So that's why you need special filters to take in only the red light from hydrogen alpha, as it's called, which makes the red light. Right? So, but because we're using a color camera, I had the option of getting a black and white camera and then just adding the images together, the red, the green, the blue, basically to make our images. But I chose the full color. Izabela says she likes the black and white images. And black and white is classic, yes, and there's no doubt about it. It's a classical approach. But in all honesty, I don't like the black and white because I just said you can't tell whether this is an emission nebula or this is an emission nebula when it's black and white. See, when we go down here, okay, and do this, right, and look at that in black and white, okay, what is this? Is this a reflection nebula? Is it supposed to be blue or is it supposed to be red? Right? We don't know. How about this? See, same way. So there's issues. There's issues, and we have to make sure that we handle it right. And handling it right means using a color camera to show us the colors.
Oh, Some astrophotographers shoot one color at a time, and they use basically monocolor with different filters on the camera, and then they build the color image from the red, the green, and the blue.
Yeah, that's what I mentioned a few seconds ago. But the thing is, I chose not to do that because, for me, I'm doing a public outreach in astronomy for everybody, and you know, Daryl's with me on this. He knows. And I don't think anyone wants to wait for all these black and white images and then see a combined image at the end, because then you would just do one image per night.
Yeah.
You know, we'd see this image for the next 2 hours. Do you want to do that? No, I don't want to do that. No, negatory. No, nunca, niet. I would not do that. Because, you know, it's going to drive people away. They're not going to want to show up and stay and hang out and watch. And I think it's kind of cool to watch this develop. Look at what's happened since the beginning. It was fuzzy. We couldn't really tell what was what. Now it's become an actual image with some very interesting detail. We have the Alniat Nebula over here. There's Alniat right there. So now we can actually take the Alniat image that I did the other night and link that with the bottom of the Rho Ophiuchi complex. So we don't have just that. We have the Alniat Nebula as well. So we can just keep going. Anyway, so there we go. So that's 23. I'm going to go to 25. I think I did that last time for the Rho Ophiuchi Nebula. I went to 25. We'll do that. And if you look where the telescope's pointing, and to see that, I got to bring the telescope back for a minute. So let's do that. Let's pull this over. Okay. Move. Come on. It'll move. There we go. So you can see the telescope is angled kind of down. All right, when you look at this telescope view here, you can see it's angled sort of southerly, and it's heading toward the east a lot. And so we're actually going to, we actually have like an hour and a half before it transits the meridian, so it's directly south. So it's still relatively in the lighter part of the sky toward the Phoenix area. So I think that's pretty interesting that we can actually, with the filters we're using, capture with such detail. This is gorgeous. Let's show the whole thing. There's the whole thing. Yeah. I don't know. That's pretty interesting. All right, we're at 25, so I'm going to save. Well, I'm not going to save it yet. I have to rename it. This is going to be Rho Ophiuchi again. Rho Oph South. All right, and we'll save it. Save exactly as seen. See how soft and beautiful it looks? That's what we're looking for. All right, now let's try doing the enhancement again now that we have many more in here. Oh yeah, now look at the detail in there. Look at that. That's pretty cool. There we are. Welcome to Rho Ophiuchi. Please enter your local Starship store in order to find out what's available for you in the Rho Ophiuchi complex and its surrounding environs. Remember, be a safe space traveler. You'll notice all these red stars in here. Some of these stars are red dwarfs and are really red, but many of them are actually red because more of their blue light has been extracted from them. And they look red because the light's been reddened by the dust, right? Here, these stars overpower the dust, and any reddening that happens to them is overcome by their own brightness because they're probably a little bit closer. But they are causing the nebula to light up like this. And we call those the reflection nebula, even though they're more scattering nebula. But that's pretty. And look at these amazing swirls. You can see these swirls that move up like this. This is great. Wow. Yep. Nice, nice, nice. All right. Save it one more time.
Asher, it's
Right.
emission, not reflection.
Curtis,
Mostly.
Curtis is in Phoenix. Curtis Horn's with us. Hey, Curtis. Um, you're in Phoenix. I was just there. I'll be back there, though, at the end of the month. And then I will be in Tucson on July 8th doing a talk. I'm speaking in Roswell. Let's see, July 1 and 2 or 3. I'm doing 2 things there. I'm doing one of these, a live audience Sky Tour live stream like before. And then I'm going to do a talk there as well. And then I'm going to do a talk in Tucson after Roswell. It's kind of funny because I'd like to say that I'm doing a talk the day after Roswell. And does anybody get the joke out there? If you do, put it in the chat. Let me know. I'm not really doing it the day after Roswell, but I'd like to say I'm doing my talk the day after Roswell. Put it in the chat if you know what that means. All right. Izabela says she knows. Thanks, Asher. Oh, Kathy. Kathy says it's a book. Ah. Gladys, so you're an alien?
What's the
Not
globulars
exactly.
in that field?
Yeah, I know. Look at them all, huh? I was just thinking that. But we're going to go here. That's what I was looking for. I hope that this will be visible. I'm kind of going north. All right, so we're going to move up a little bit. And we're going to hit the wall a little bit with this one. Okay. I'm rushing summer, aren't I?
Little.
A little bit. I'll tell you what. Once we get this in here and locked on, I'm gonna do a exposure that again we're at 257 for this. I'm gonna go. I'll just do it at 325 sensitivity. Okay, and now we're stacked. I'm sorry, we're actually guiding just fine. I'll do a 45-second shot here and take us out of our night vision mode. Go into the live stack. Gosh, that's beautiful. Look at that thing.
I posted an image during the last stream
Okay.
of showed the whole the west side of the Milky Way and the Pipe Nebula and the Dark Horse and over to Rho Ophiuchi on. God, you got me doing it now. Ophiuchi on the right. You can see the dark streamers running all the way from Rho Ophiuchi to over to the Dark Horse and the Pipe. It's a striking picture.
Yeah. And so
All one
let's
big
take a look.
complex to dust and stuff.
Let's see if this worked. Oh, we're getting the red of the tiny little LED on the end of the camera. hitting the building and being reflected back. We're not quite there yet. We need a little more time. We can't see it too well, unfortunately. It's like looking at it through like a 2-inch reflector. Okay. I guess we'll have to wait till a little bit later in the season, won't we?
Or late enough at night.
Hmm.
You probably could see the blue Horsehead, though.
Yeah, I'm thinking that we can.
It's just
The blue Horsehead's
below,
back the other way.
Of, Rho.
Yep.
I was looking for that one picture again, and I came across the other one here that shows a closer field, and it's called the Blue Horsehead. Sits just to the lower left of Rho O.
It's right there. It's actually to the upper right of Rho Ophiuchi.
The image I saw was upside down then.
Yeah, I bet it was. Okay, well, let's try this. This will be fun. And I know we can see this. Telescope's going to come up a little higher now. There we go. All right. And we'll see as we zoom in on this. I'll show you. Okay. All right, and let's do this. Wrong one. I want to do this. There we go. Okay, so there is a bright star there. I gotta go see what that one is. It's probably Jabbah. So we're probably...
Jabba the Hutt.
That's right, we're probably here. I'm not sure. Well, we're going to try it. We'll see. And then I'll figure out exactly where we are. Okay, and now we'll do 35 seconds here. That's underway. And then go into our live stack. And clear this. This one's definitely in the clear above the building. All right, 5 seconds. 2, 1, and kaboom. Let's see what we got. Oh my, look at that. We got this beautiful blue cloud. It's a substantial nebula. Kind of reminds me of the Witch's Head. This is one that we would need to do as a mosaic, don't you think? Just to capture everything.
Yeah, it looked like it was spilling out of the field of view in Stellarium.
Yeah. Yeah, this is our field of view. And if that's where we are, I'm going to guess that that's Jabbah. And that this is a crab over here. So we're kind of... I think we're kind of like this right now. I think that's kind of where we are. Because Jabbah is right in the middle of it, if I recall. Yeah. So that's Jabbah right there. in right here. And this is this beautiful nebula right there. And we can see that it has a transition from this blue reflection nebula to that dusty and hydrogen-laced environment. And we only have three of them that are actually stacked right here. I'll tell you what I'm going to do. I'm going to get out of this because I'm going to move it over. I'm going to move this star over here and probably keep it right at the same level to catch the other side of this, because there's a lot more going on over there. So we'll do that right now. Very, very sharp distinction there. Okay, so now we'll come back in here, and we're going to head to the east. Swing the telescope to the east. Without moving much of anything else. Yeah, you can actually see the cloud here. That might be about it. Maybe a little more. Okay. Okay. And now we're searching for the guide star again. And once we find the guide star, you'll see it up there. Come in and we'll be ready to do another shot. And we're going to do 45 seconds again. Okay, we are stable. So here we go. Focus looks good. We're going to live stack here. And now this is going to be all the way over here. So we'll see more detail in this without losing any of this detail that we're seeing. So we'll clear that. We got 20 seconds left on the clock. This exposure. And we will wait for it to come in, do some processing, and then go full screen again. Okay. Here we go. You see how much noise is in the very first image? And then that's going to change. With the second image, you're going to see a lot of it gets subdued. And to prove that, I'll zoom in. Okay. So we have 19 seconds left. Oh, I see. I think we got to refocus too. Yep, we got to refocus. Well, I'll let this show up. So watch the color noise here. Watch how it goes away. Ready? Boom. See how that... Now look at that. It goes away almost. That's good. Alright. There's the whole nebula right there. That's a nice shot of it. Okay. We'll be back to this in just a minute. We're going to just take a little break to focus again.
You look at that short image there, and it looks pretty crisp. You can make out the double star well.
Yeah. All right, so now we're gonna pull focus out. There we go. Make our little donuts. Okay. Now we'll do our focus. We're going to focus and scan inward. And we're going to build our parabola, our focus parabola. At the bottom of that parabola, where the star brightness of the star takes up the least amount of space on the sensor, basically, that'll be the most tiniest image of the star possible, and that's going to be the focused star.
Well,
And each yellow square is the samples we're picking to do that. Go ahead, I'm sorry.
That's analogous to focusing a telescope through the eyepiece. What you try to do is make the stars as small and sharp as possible.
Yep.
That's how you know you're at sharpest focus.
Mm-hmm. Okay, so we're up to 99 stars, and we're going back out of focus, so you'll see it go down to lower star counts. It has more stars that it can focus on when some of the fainter stars become focused later. So you'll see fewer and fewer yellow squares, and then it's going to put, how's it going to put it there? It's going to put the curve of best focus point right there. I'll let it finish out, and then it draws it. It forms a line. Okay, it does a curve, a best fit curve. So now we're going to go to best focus. There we go. Goes all the way back out, and then all the way back in. Now we have good focus. There we are. And now let's do 45 seconds on the Blue Horse Nebula. I'll put T-Comp back on. Alright. And we'll take off our night vision mode because that just makes it look too bright. So let's go back in and see what Daryl was talking about before. Here you can see a nice image starting to form of the Blue Horse. Yep. And we'll clear this one because we needed the stars focused. You'll see a definitive difference in the focus of the stars in this. Two seconds. And bam. Give me my nebula. Look at that. Much better. Yeah, so you already see some nice detail in here. That's with one frame. Look at the emission nebula up here, the hydrogen emission nebula. We've got the blue reflection nebula. Undoubtedly, there's hydrogen there too that's ionized, but the density is probably very low, so the blue dominates the field. Look at that. One frame comes in and immediately you start to see more detail. That's really something. Okay. Here's our curve. You see the red, green, blue curves here, and the white curve is the average curve. And so we basically use that as our guide, and this is our dark level. So if I was to pull that dark level really over the top of the curve, you'll see how we lose almost all the nebula, and then it's gone and it's just stars. So we want to be kind of on the 3/4 side on the left. And this is a middle level. So if we have a mid-level, we can actually see how much stuff's actually here. Look at all that congested dust and gas. Pretty cool. Very nice. I use this one to show what's really there. If we pop that up, it actually gives you a kind of a sort of a bird's eye view of what's really there.
It's interesting.
Yeah. This very sharp line is interesting to me.
So is that reflection or emission?
This blue is reflection nebula.
Okay.
Is that what you're asking, right?
Yes.
Okay. This is the blue horse, yes, Izabela.
Horsehead.
Cosmic Ray says, how about a Nina imaging session? You know, Nina is meant for, more for the individual. I don't think it's meant for mass consumption, and that is to say, to have lots of people watching at the same time. This is a very interesting screen, lots of information, lots of cool stuff. And I just think that many of the programs are targeting the individual astronomer or the individual who wants to do astrophotography. And I'm not, I just think that there has to be something really cool. Let me move that. And let's get rid of our scope for now. I just like, I like showing this as it is like this. I don't know what it is. I just love it. That's beautiful. Look at all that. It's just beautiful. By the way, folks, Nina is a program to generate and do some astrophotography. In fact, I have it right here on my desktop. Nina, there it is. But I don't use it because I just didn't feel it was conducive to showing you the universe live in real time like I do. And that's what we do. The universe live in real time. We made a few minutes here just to... Notice the filamentary structures here are starting to show up a little more clearly.
I posted a link in chat of a nice wide field view of the Rho Ophiuchi area, and it shows the entire blue Horsehead very well.
So it must have been upside down because the blue Horsehead's to the upper right of Rho Ophiuchi.
Yeah.
Okay.
Let me look again.
Izabela says,
yes, I think so. In the image, all the dark clouds are streaming to the lower right in the image, and when we look at it in the northern sky, we see it streaming to the left.
Oh, it was taken in the southern hemisphere, maybe.
Yeah, probably.
Izabela says, I don't like pareidolia. Once I see something, it's very difficult to unsee it after that. You mean like a sleeping woman in Rho Ophiuchi, Izabela, which I cannot unsee now? She did it to us the other day.
Oh, I know. I got in trouble for that.
Look at this. Look at how this detail is shaping up nicely here. Sam is, that's one ugly horse. Well, yeah, I guess it is an ugly horse. You should have called it the ugly blue horse. So... Izabela says, very beautiful mosaic. Mark, we have to make the mosaic. I agree with you. Okay, let's redock this. Okay. Let's bring back the telescope. Right. Oh, this is 12 shots so far stacked. It's really nice. Yeah, I'm really liking this. Very subtle colors, you know. I mean, the Rho Ophiuchi complex, and this, of course, being an offshoot of that complex, is just stunning. There's so much going on here. Now, it's funny, okay? Reflection nebula like this are not nebulae that are subjected to the extreme high temperatures that, say, an emission nebula is. Now, these stars are capable of generating those kinds of temperatures, I'm sure, but we don't know how far away this cloud is of dust. It might be far enough away so that its hydrogen isn't ionized. Maybe this cloud's actually closer to the star than this stuff here. Okay, this could be farther away and this closer, so this is being ionized and this is not. So that's why these dark nebulae are the plentiful sources of life-giving material, because there's nothing to rip them asunder and to destroy them. You know, it's pretty interesting how it all works. So this is neat.
Interesting. The star that's illuminating the reflection nebula is New Scorpii.
Oh, yeah?
Multiple star system in constellation Scorpius. Most likely a septuple star system, 7 stars.
This one? That's Jabbah, isn't it?
Let me get back to yours. The bright one with the halo over on the right.
That's Jabbah.
You say so.
Yeah, I'll show you. Let's go look. Oh, well, first let's bring us back to it. This is Jabbah.
Okay. Click on it. Does it say...
It's 14 Scorpio. It looks like... It doesn't... Looks like a V. I can't read that. What are the other designations for it?
Give me just a second. Yes,
Right
V
here.
Scorpii.
Okay. Goody.
Oops, where'd it go?
I wasn't kidding.
Septuple star
Izabela.
system, 2 close groups designated New Scorpii A, B, and C, D that are separated by 41 arc seconds. I suspect that's the weird star that Gladys wondered about earlier. It was showing up as the double, and it's actually 7 stars in groups of 2.
Yeah, that's is
And
that this
yes,
one or
it's
is it-
also named Jabbah.
Okay. I love these filaments here. This is just stunning. We're at 17 exposures on this. We'll go to 20. Oh, Sam S. Says he sees the horse. Is this the head of the horse and part of his mane here?
No, it's the blue horse head.
Well, it's the Blue Horse Nebula, right?
It's the blue horse head nebula.
Oh, the Blue Horse Head, right?
Yes.
Okay.
The whole thing is the head.
Oh, yeah. So the whole thing is this whole thing, which we don't have the whole thing.
Uh-huh.
We still would have to check out IC 4601, which is literally, let's see, we're here. No, we're here. So I think we are catching just a little bit. If this is Jabbah, so Jabbah is there. Actually, let's zoom out. Oh, interesting details showing up now. Auto. Okay, there's the whole image. Look at that. That's beautiful.
Michael H. wants to know what that beautiful gold object is down at the bottom left. It's another star.
Yeah, actually, that's what I was just identifying. Because right now, I believe that it is. We're like right here. I think it's this guy. Let's see. It's a white star. I don't think it's this guy. Maybe it's this guy.
I think maybe so.
Yes, this is a K03. So this is a giant K0. So it's an orange star. So our frame is right here. See that right there? That's this right here. That's Jabbah. And that is the K03 star. That's it, Michael. That's what that is. If they're talking about the star, I believe that's what you're talking about. Let me know.
I think so, yes.
The star in our solar system, Michael, is a G2 star. So G is ahead of K. So we have O, B, A, F, G, then K. G stars tend to be whitish yellow, and then the K stars tend to be orange. And then the M stars after the Ks are red. Oh, look at that. I said I'd go to 20, but I need to go a couple more.
I'm going to turn into a pumpkin soon.
Well, you're going to be doing a lot of pumpkin turning over the summer.
Yeah.
But I got it. I understand. It is 2 a.m. here in the East Coast. I should be turning into a pumpkin long before you, Daryl. It's all right.
Yeah.
That's all right. Let's go to 100%. Okay, so you can see there's still some noise left in our blue nebula. We can get rid of all that. We can get rid of all that. Okay. And now we'll zoom back out. Okay.
JM UFO has a question for you.
JMUFO, good night from Brazil, Marc. Have you done research in Zeta Reticuli region? No, actually, I haven't, except for the except for the popular Zeta Reticuli alien theory. What?
Oh, I brought that up on KGRA stream once and a radio show, and they all
Okay.
made
About Zeta
fun of me
Reticuli?
for mentioning. Huh? Yeah,
Zeta Reticuli?
the name of the planet there where we supposedly traveled with aliens.
Okay.
They all
Yeah.
made fun of me.
Well, here's the thing, okay? When I forget her name, who first came out with a star map to talk about Zeta Reticuli. Okay, was that Betty Hill? Or was that something else?
No, the Zeta Reticuli thing was supposedly a secret government program where humans had traveled to a planet that orbits Zeta Reticuli.
Oh, was
And
that Project Serpo?
Serpo, yes, that's the name.
Okay, yeah. Well, Serpo's, to me is nonsense. I don't think that's true at all. I think people just wanted to sell books who wanted to talk about it, to be honest. But as far as Zeta Reticuli, I mean, it's interesting when we talk about Zeta Reticuli and the nature of the star itself. I mean, there might be a possibility that we'll find lots of life around other stars, and not necessarily intelligent life, but it's very possible.
Yeah,
As far as Zeta Reticuli, I don't remember the stellar type of Zeta Reticuli. Let me look it up.
I already have it.
Okay.
It's let's see. It's a G3 minus 5b, G3 5b plus
Yeah.
G2b. I guess a double star.
Double star, yeah.
It's way down in the southern sky. We can't see it. It's at minus 62 degrees 30 minutes.
Okay. All right. Well, okay. That's cool.
Constellation Reticulum down by Dorado,
Yep.
near the Large Magellanic Cloud.
Yeah, we're gonna see the Large Magellanic Cloud. I just wanted to let everybody know also. Um, do check out skytourlive.org, okay? And consider becoming a $25 a month patron with us, because this is stuff that we're bringing you this stuff, and this is coming out of our pockets. I'm not getting any pay to do this. This is something that I'm very passionate about, so I'm hopeful that you can enjoy that passion enough to help us keep it going. So, and if you give a $25, if you do join as a $25 patron, you do get a SkyTour live stream T-shirt. I feel like a CP, like a public television telethon or something. It's like, if you give us $4,000, we'll give you this red Solo cup. It's like, the gifts never seem to match the donation, which I think is. Well, we're doing good here. This is looking nice. So this is 30 images. I'm going to stop it here. And I'm going to... this is not Rho Ophiuchi South. This is the Blue Horsehead. Blue Horsehead Nebula. We'll save it. Save it exactly as seen. Alrighty then. Wow. So much for rushing the summer. I'm going crazy here.
Heck, it might be up high enough by now.
You thinking what I'm thinking?
What?
Talking about Antares?
Whatever you were trying to image early on there when we could see the halo of Antares was being cut off by the roof there.
Yeah. There's the double star that is Jabbah, and it is actually more than two components. That could be up to 7 components. There's going to be spectroscopic binaries in there as well. See that?
Yeah.
That's Jabbah. I like it. Okay, so let's see. Oh, this is beautiful. Yes, I'm very tempted. I'm reading Izabela's mind. I'm very tempted to actually do a mosaic here, but it won't stop because it's going to go all the way down to Rho Ophiuchi and down to Alniat and beyond. Now the Antares Nebula, I'd love to image that, but the trouble is Antares is so bright. It makes it really difficult to image that. Really does make it very difficult. Let's try the Dark Horse Nebula one more time, which is what you're talking about, Daryl.
That's a pretty extended object.
I know. However, we're going to have the ability to do it because it's above it's above the roof. All right. Very good, very good, very good. All right, so let's see here. Okay. We're going to make this a 45-second shot. It's probably too much. Nah, I'm just kidding. Probably not quite enough. So let's get out of that and go into our live stack. There it is, that beautiful image. I can't wait to see this, how it comes out. All processed. Look at that. Blue nebula throughout this image. When have we ever seen that? And then we've got this beautiful area up here. Just gorgeous. And it is screaming for a revisit. Okay, 1 second. And now our first shot. Oh, look at the dark horse. Alright, I'm going to move it over a little. So we're going to get out of this. We are now looking more closer to the center of the Milky Way. Alright, and let's go into our night vision mode, and we're going to move this over here. So we're going to head to the east with our telescope. There we go. There's the dark horse. You ready, Daryl? You ready for one more?
Sure.
All right.
You're actually capturing about the upper half of the dark horse.
Yeah, I know. I can't get all of it.
Yeah.
Flicky. Okay, Dark Horse Nebula. Maybe I can drop it down just a tad and maybe go eastward a little bit more. I think that's probably going to be the best we can do for now. Oh, yeah, our theme music did play. I meant to take it out of our loop. Sorry about that. Because when you hear it, it means it's about to end. That's still true. But I've changed that because I now have a startup and ending video that we show. It's the same video right now. I'll have an ending video that's different next time, and it'll play with the same music. Okay. Let's do this. 45 seconds. Off it runs. That should be good. Yeah, see, I moved that all over here. So you're going to see this. And that's going to be a little bit higher. Wonder what that looks like if we... Oh, man, that's going to be beautiful. Those are all stars. All stars. Temperature in the building is 23.81 Celsius. There we go. That's kind of what I expected. Look at that.
The curved line you see, middle right, that is the
This one?
horse's front. No, the one in the middle right,
Oh, this one?
right there. That's the horse's front leg.
Yeah.
The thing up at the top, you're viewing it at a scale where it's kind of breaking up. No, not that. The one to the top left, right there.
This?
That is the horse's head. It doesn't really show well. We're looking at a close enough view of it that it kind of breaks up. You see the horse's head easier with a very wide field shot, like a camera at a normal lens or something, you know. Much lower focal length. That's the horse's head, though. And then his front leg, he has his leg kind of raised, and that's his hoof on the end there. The lower part of the horse's head is out of the field of view at the bottom. It's the pipe nebula that I mentioned before, which the stem of the pipe points right toward Antares, and the bowl of the pipe makes the horse's rump. And the center of the galaxy is just to the lower left of the bowl of the pipe nebula.
Okay.
Just out of field of view at the bottom.
Hey, Calabos, how are you? And hello, Alpha Centauri Virgo, how are you? Welcome to Skytour Livestream. Make sure you subscribe, you know, because this is the universe live in real time. Actually, let's try to process this now. How's this for spectacular? All right, and you'll notice the stars take on a much more red-yellow look when we're here, because we're actually looking more toward the center of the galaxy where we have more yellow stars. So it's very cool.
The big dark blob at top right, and the other streamers there with it. That's some of the dark nebula streamers I mentioned earlier that run all the way back over to Rho Ophiuchi.
Mm-hmm. That's beautiful, I'll tell you. Let's turn off the unsharp mask for a moment. Okay, this is more of a natural shot. We'll leave that running for now. Okay, this is the dark horse. I remember when you and I found this when we didn't have the we did not have the alignment of the telescope at the time. I think we wandered into this, and it's like, wow.
I think so.
It was amazing to see how much detail this telescope was pulling out. Gladys says, Mark, has the universe ever given us a sign, given you a sign as you were on live? I'm not sure what you mean by that, Gladys. Please clarify that for me, Gladys. Calabos, that's good. No, you can't complain, right? It's like, no one will listen anyway.
Could I make a suggestion?
Yeah?
Start over and bump the image up to the north just a little bit.
Well, then we'll lose this arc.
No. Go north.
Oh, to bring this in?
To bring all that in. I mean, the big dark blob just above center, okay, the central part of it.
Yeah.
Lower that a little bit more toward the center.
Okay. And go this way?
Up.
I know, but go like this way? Move this down here or just down here?
Either. Maybe a little to the lower left.
Okay. All right, well,
Generally
since
that
we're going to
way.
do that,
Just a little bit.
all right, I'm going to actually save it here so we can actually make a composite of these 8 frames with the ones that we'll do from that one so we don't lose this. Okay, so now we'll clear that and go back to our night vision mode. And from our night vision mode, waiting for night vision mode. Oh, duh. Hello. I was supposed to do this. Okay. So we'll take this star and move it down here. Okay?
Just a little.
Yeah.
Probably good right there.
Yeah? I'll just do one more jog.
Okay.
Muted. Okay. Let's try that. We'll do the same amount. And we are guiding stable. Good. And we can bring this now a little larger. Okay. Now let's do our live stack. We have 20 seconds. That's cool. Alright, so we'll clear it now. 7 seconds left to go. And that whole thing should be, that black object will be in view. But not until I do this. There you go. Is that what you're looking for?
Yeah, more or less.
Yeah. Okay, we'll do 8 shots like this, and then we'll move on or move off.
Some of those streamers are very intricate.
Yeah,
And
they
they
are.
wind all the way over to a Rho Ophiuchi out of screen on the right.
Mm-hmm. I hope you guys are having fun tonight. Let me know in the chat. All right, while we're doing that, I'm going to look up a couple things here. Okay, our connection is excellent, which is nice. Very good. I'm just checking our stream health. It is very good. Nice, nice, nice. I'm red because the M-class stars are shining their light on me. Okay. Let's take this down a notch. So this is where a black and white image would not hurt. Because see here, we know that the stars are just a variety of colors, but not that many different ones. And then we'd see this dark nebula very much silhouetted by the stars behind them. And sometimes it's harder to see when you have all the color in the view at the same time. I just prefer color.
Color's nice.
Yeah. Thank you, Izabela, for putting that up. The blue Horsehead and the dark horse. Okay, we're at 6, 7. One more. It will match the 8 that we did for the other. And then we'll be set. Now we can do a mosaic of these two. You can see the detail now coming out, which is really cool.
Yeah.
I didn't want to stop at 8, but it's getting late. So I had to stop at 8 because it's getting late. And I won't rate. And I'll have a horrible fate if I don't get any sleep.
It's late. No, it's late. I'm late. I'm late for a very important date. Who was that?
Oh, the Alice in Wonderland. It was the rabbit, or was it who was the rabbit with the clock?
Yeah.
Okay, there we go. Dark Horse Nebula one more time. Saved, and saved exactly as seen. There we go. Yep. And there's the ping file. So that is also available to you. This is what it looks like. That's the pink file. Now we could just do some quick modifications here just to see. We could increase contrast a little bit. And apply it to the original. See that? So you can do some things, you know. So that's up there. It'll be there in a few seconds.
Interesting. The tendrils really stand out now.
I know it. That's right. I should have gone to 10, but it's 8 and 8, and I'm not going to save it beyond this. We'll do this again as needed.
Okay.
All right, folks. Well, look, I am tired, and it's time for me to hit the hay, and I still have to close all this stuff up. So that's what I'm going to do. I hope you guys had a good time. I sure enjoyed having you with us. So hopefully you guys will be here on the next time we stream. And I look forward to it. Make sure you visit skytourlive.org and check out everything we have to offer. Think about the Patreon. Obviously, you can go to this stream and subscribe as well. Make sure you do that if you haven't. The more subscribers we have, the more we can do. Yeah, actually, to be honest, Izabela, I know I say I'm tired. I've worked all night before, you know, and by the time morning comes around, I'm tired, but the adrenaline is just flowing, so it's just like I'm up, you know. But tonight I have to get to bed because tomorrow I have things to do in the morning. But check it out. All right, since I'm up to 11, I'm just going to save it again. It won't be that different. Okay. Wow. Okay. Well, there we go. And if you want to watch the shutdown, I'll do that with you. So, first things first. Back in the night vision mode. And we don't need this anymore. So we can get rid of the planetarium. And now we're going to actually park the scope. It goes to its predetermined location, which you'll see. Okay. There it is. Move into its predetermined spot. And the scope will tell me that it's turned. I can turn it off now. So you'll see the handset go off now. Boom. Scope is off. And it is parked fully in this final position. There's the camera in the end of the telescope. This is the glass front plate. This is a dew shield, which we don't have to worry about there. But interesting. And now, what we can do is we can shut the roof because we are now parked. And the telescope is in that position where we don't need to worry about that. So I can actually come in here and shut the roof now using my program I wrote to do all this. And there we go. We're going to bed for the night.
You ever considered putting a piece of electrical tape over that red LED on the front of the camera?
Yes, I have. I've thought about doing that. Yeah, definitely thought about doing that. Yep. Okay.
Good night, everybody.
Yeah, I hope you guys have a good night. And we will be returning, on another clear night. So until then, we'll talk to you again. See you later, folks.